So now that we have our different methods for solving systems, we're going to look at word problems associated with systems of equations, how we set them up, and then using those methods that we've learned to solve for x and y. So my steps for setting up and solving word problems. First thing we're going to do is read through the statement and highlight any important information. Then we're going to identify what we're comparing, so defining what x and y equal. Then we set up our equations, and then using elimination or substitution, we're going to solve for one of the variables. Once we have that variable, then we plug in for the other and solve. Now the last step there, number 5, we need to answer by stating what x and y stand for. So we want to make sure that we answer the problem using the appropriate words or units that are involved in the problem. So there are a couple different types of problems we're going to look at. The first type, so type 1, is when my equations are set up in slope-intercept form. So looking at the box down here, before we read the statement, we use this type when there are slope and y-intercept words in the problem. So my slope words are per, each, of, every, okay? Y-intercept words are things like initial, beginning, and like a one-time fee, okay? So when we read our statement, we're going to look and see if we see any of those words. So reading the statement, the Smith family is trying to decide between installing cable TV or purchasing a DVD player and renting DVDs. The Smiths need to compare the cost of each option over several months in order to make an appropriate decision. So for cable TV, okay, there is a one-time installation charge of $45, and then it is $34 per month. Okay, so I see the per is my slope word, and I have that one-time charge, which is my y-intercept, my b value. So for cable TV, and I'll do this in blue, we're going to have y equals, so we have the $34 per month. So 34x, and then the one-time installation charge of $45, so plus 45. So in this problem, my x represents the number of months, and the y is the total cost. Okay. Now, let's keep reading. So for the DVD player, it costs $185 to buy one. Okay, so that would be like that one-time charge. And then it's $20 per month. So there's that slope word again, per. So for the DVD option, I have y equals the $20 per month, and then the initial charge of buying the DVD player, so plus $185. So I have my two equations. They are both y equals. So I'm going to use substitution here. And I notice that this is what y equals in the bottom equation. And then when I look at the top equation, I have a y right here. So I'm going to basically set these two things equal to each other, right? I'm going to substitute y for what y equals, which is 20x plus 185. And that would look like this. Equals 34x plus 45. So to solve this problem, I want to get my x's to the left and my numbers to the right. So first thing, I'm going to subtract 34x. So I would have negative 14x plus 185 equals 45. Then I'm going to subtract the 185 over, and I get negative 14x equaling negative 140. Final step, I just have to divide that negative 14 off. And I get x equaling 10, and remember, x is months, so 10 months. Okay, so I have the number of months where my two equations would equal each other. Now I just need to find what the cost will be. So I have to plug in 10 into one of my equations, and it doesn't matter which one. I'm going to plug into the bottom one. So y equals 20 times 10 plus 185. 20 times 10 is 200. So my total cost would be $385. So my final answer, I want to write the sentence. They will cost the same after 10 months at $385. Okay, so that's dealing with type 1 when I have y equals and y equals. Now let's look at type 2. So type 2 is when I have standard form, so x and y on the same side, and a total number. So again, looking at my box first, we're going to use this method when you're given one total amount and one total number. Okay. And usually you'll see at least two slope words or ideas in the problem. Okay. So let's read through the statement. The Madison Local High School Marching Band sold gift wrap to earn money for a band trip to Orlando, Florida. The gift wrap in solid colors sold for $4 per roll. And the print gift wrap sold for $6 per roll. Okay, so there's those two slope words, per and per. So we see that the total number of rolls sold was $480, and the total amount of money collected was $2,340. So we have the total amount, and we see the total number. Okay. Now, when I go to write my equations, we want to keep the same units in the same equation. So the thing that I always try and think about is I want to do, in this case, money, money, money. So I see that I have $4 per roll, $6 per roll, and then the total amount of money collected was $2,340. So money, money, money. All three of those numbers are going to go into the same problem. So before we start, let's establish what x and y equal. So x is going to be the solid color gift wrap, right? And y is going to be the printed. Okay. So setting up that first equation, money, money, money. So we have $4 per solid color, $6 per print wrap, for a total of $2,340. So again, I have my money all in the same problem. Now, to get the total number of rolls sold to be 480, so I know that this is going to equal $480 or 480 rolls, right? If x is the number of solid colored rolls and y is the total number of printed rolls, to get the total number of rolls sold, I would just add those two things together. So x plus y. Now, you can solve by substitution if you want. I'm going to solve by elimination though. So I want to get my x's to cancel. The top one is positive 4x. So I need to multiply the bottom x by negative 4 to make those cancel. So I'm going to multiply the entire bottom equation by negative 4. So my new equations, I didn't mess with the top. So 4x plus 6y equals 2340. Bottom equation becomes negative 4x minus 4y, negative 480. So the 4x and the negative 4x cancel. 6y plus negative 4y is 2y. And then 2,340 minus 480. Oh, sorry, that wouldn't be 480. Negative 4 times 480 would be negative 1,920. And again, use your calculator for that, right? So 2,340 plus negative 1,920 leaves me with 420. So dividing by 2, I get y equals 210. And y was the number of print gift wrap sold. Okay. Now I just need to figure out how many solid colors I sold. So I'm going to plug into that original bottom equation. So x plus 210 equals 480. Subtract the 210. I get x equals 270. So that would be the solid wrap, right? So to write my sentence, we would say they sold 270 solid color and 210 print gift wraps. Okay. So the last problem is when I have, or last type, is when I have two standard form problems. So I would have two equations like the first one here, okay? So looking at the box, we would use when we're given two total amounts or costs, which explain the same situation at two different times. Okay, so that's how this one differs. It's going to be two total amounts that are asking about the same thing. So reading through this statement, it says the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, they sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 children tickets. And it's asking us to find the price of a senior citizen ticket and the price of a child ticket. So, identifying my variables here, X will make the senior ticket price, and then Y will be the child ticket price. So, setting up that first equation, the stuff I underlined in blue, we had 3 senior citizen tickets and 1 child ticket for a total of $38. So that would be 3x plus 1y, we don't need to write the 1, for a total of $38. That second equation is written a little bit backwards, right? It gives me the total amount first, so $52 is how much they made on the second day. And they sold 3 senior citizen tickets and 2 child tickets. So 3x plus 2y. Now again, I'm going to use substitution. And I see that my x's are the same number, but not opposite sign. So I'm going to multiply the top one by -1. So my new equations, I would have -3x minus y equals -38. Bottom equation, I would have 3x plus 2y equals 52. -3x plus 3x would cancel. -y plus 2y would leave me with y. And then -38 plus 52 would leave me with 14. Now, I already have y equals. I don't have to solve for it. So y, the price of a child ticket, would be $14 per child. Okay. Now that I have y, let's find x. So I'm going to plug into the original top equation. So 3x plus 14 equals 38. Subtract the 14. 3x equals 24, and then I divide. And I get x equals 8. So it's $8 per senior ticket. So my final answer it costs $14 per child ticket and $8 per senior ticket. And that's it.